Acceleration. As you have learned, speed describes how fast something is moving. However, sometimes if we are following how fast something is, we also need to know the direction it is going, like perhaps an incoming thunderstorm. If we know a thunderstorm is moving at 10 kilometers an hour, we would also need to know if it is moving in the direction of perhaps maybe a baseball game you have planned for the afternoon. In this case, to know the speed and direction of the storm, you need to know the storm's velocity. Velocity is the speed of an object and the direction of its motion. Using our same reference of the thunderstorm, if we hear over the radio that the storm is accelerating to 15 kilometers per hour, then we know that there has been a rate of change in velocity. When the velocity of an object changes, then the object is accelerating. Remember that velocity includes the speed and direction of an object. Therefore, a change in velocity can either be a change in how fast something is moving or a change in the direction it is moving. Acceleration occurs when an object changes its speed, its direction, or both. To calculate the acceleration of an object, the change in velocity is divided by the length of time interval over which the change occurred. So to calculate the change in velocity, you subtract the initial velocity, or the velocity at the beginning of the time interval, from the final velocity, or the velocity at the end of the time interval. Looking at this formula, VI will stand for initial velocity, and the symbol VF will stand for final velocity. We use a delta symbol or a triangle to represent the word change in. So delta V, or change in velocity, equals the final velocity minus the initial velocity. You can use this expression divided by the time it took to get your acceleration. The unit for acceleration is a unit for velocity divided by a unit for time. In SI units, velocity has units of meters per second and time as units of second. So acceleration has units of meters per second squared. Generally, when somebody uses the word acceleration, we think of something speeding up. However, remember we said that if there is a change in an object's speed or an object's direction, then it is accelerating. Looking at this plane taking off, we know that it is speeding up. If the speed of an object is increasing, then it has positive acceleration. If you were riding a bike and you started slowing down to a stop, your speed is now decreasing. Since the speed is changing, the bike is accelerating. However, since the speed is slowing down, then the bike has negative acceleration. Looking at this formula, the initial speed was 3 meters per second. Then you slowed your bike to a stop for your final velocity of 0 meters per second. If this stop took 2 seconds, by using the acceleration formula, your acceleration will equal negative 1.5 meters per second. Now it's time to show what you know.